Okay, so this is a little demonstration on how to do this assignment. Now this is just sort of mixing a little bit of earth science and the physics that we're doing right now. So you are actually going to determine the speed that crustal plates move. And we're going to do that by using Hawaii as an example. So a little background on this. This talks about it, so make sure to read it. But you can see here that there is a hot spot, and the hot spot is coming up and bringing magma through this crustal plate. So this is the plate, and the plate is moving because we know that plates move. And what's happening is it's showing us that as the plates are moving, volcanoes get created, and they're volcanic islands. So similar to Hawaii, and this is how Hawaii was formed. Okay, as the hot spot created an island and then the plate moved, that volcano would move off the hot spot and a new one would be made. So you got your first volcano over here that was once on the hot spot, and it's moved the farthest away, and then the second one was made and the third one was made, and now it's currently on the fourth one, and it's being continuously built upon from this magma and these eruptions. Now these volcanoes are extinct. They don't erupt anymore because there's nothing feeding it. There's no magma from the mantle down here feeding these volcanoes, so they're extinct and they're just now islands, while this here is the active island. Okay, so Hawaii is like that. So I'm going to jump to the next page. Now my printer is terrible, so I apologize that you can't see the numbers very well, but we'll walk through it. So this is saying that we have the Hawaiian chain here now. So we're going to talk about some of the bigger islands. We've got Hawaii, Maui, Molokai, Oahu, and Kauai. Those are the main islands that we're actually going to be measuring. And you could see they plugged in some of the smaller islands as well. So what we have here is a map. Okay, notice you have a compass legend over here. This tells us, okay, going up is north, east, west, south. Okay, so if you're familiar with a map, you should always look at which direction things are going. You also have a little scale that's giving us how many kilometers. There's my printer again. So we could measure this out, and then that is going to give us kilometers. So we are going to need to be able to do that. So it says, using the scale shown on the diagram, I'm reading the directions, determine the distance between the 5 major islands and enter your answers in the appropriate spaces of the data table. So here's your data table down here. Okay. So we're going to be finding the distance between Hawaii, Maui, Maui and Molokai, okay, Molokai, Oahu, and Oahu and Kauai. So those are the 5 major islands that they have put dots for, and we're going to get the distance. But in order to get the distance, you have to have some old school map skills. So looking at the scale, you can do a couple things. So if you don't have this printed out, you can just go onto the computer with a piece of paper, just like I'm doing, and do it on your actual screen. Okay, be gentle on your screen. I know our Chromebooks fold all the way back, so you can lay it down and you can make a scale the same way I'm doing it, but use your screen as the scale, and you can do all your measurements on the screen as well. So you can pretend your screen without writing on your screen and do the same thing I am doing with this printed copy. If you can print it, it might be easier for you just for the scale purposes. And then you can fill out all the data in the document in Canvas. So you don't have to do all the data in this data table if you print it, but some people feel more comfortable printing just this page so they can do the scale. But this works on the computer just the same way you can make the scale. So what I'm going to do to get the scale is I'm going to get a piece of paper that's blank. And I'm going to draw this scale on the paper because I'm going to need to use it as a measuring device. You can also use a ruler. Some people will use a ruler, and they might note that each one of these is an actual centimeter. Okay, and they might measure it with that. But do note that in your Chromebook, if you've made your diagram over 100%, then these aren't going to be a centimeter anymore. So whatever you do, I would just use the paper in this case if you're not going to actually print a copy. So what I'm going to do to make the scale is you can start on the edge if you want to. You don't have to. I don't like to start on the edge because I always find that I end up folding the edge and then it's off. So I'm just going to mark this exactly how I see it. That's going to be 0, And I'm going to mark these little guys in between because you're going to want those. And that's 50. So if you count this out, you probably know that 0, then this would be 10, 20, 30, 40, 50. So each little notch is going to be 10. Okay. And then there's 100 and 150. So we got 100, we got 150. Now I know that there are a couple longer than that, so I'm just going to keep going a couple notches. So if each one's 50 and I make another notch here, then I know that's 200. And I might just go one more, 250. So I can kind of say, oh, if I have to go between two islands, I can see the distance is however much if I had to go beyond it. I probably didn't need to go all the way to 250, but that just makes it easier. Now, and you also will want to make these little notches in between because some of them are not right on the big numbers. And instead of guessing, it's just quite easier to have your, oops, that's a little off. It's easier to just have your notches. So again, you can hold your paper up to your Chromebook and trace this right along the Chromebook. I think we don't go beyond 200 in the distances. So I'll just leave it at that. So now I have my little scale drawn so I can make my measurements. Okay, so the first thing that they want us to do is Hawaii and Maui. So I'm going to do a distance between Hawaii and Maui. So I'm going to put, and they want them from the circles. So circle, that's the center of the island to the other center. So that gives us a good idea of making sure we're not going edge to edge or anything, okay? So I'm going to put the 0 right on the 0 at Maui, and then I'm going to find the center of Hawaii, and it looks like it perfectly lands on 150. So remember, our scale is in kilometers. So that means the distance between the two islands in kilometers is 150. So you want to make sure you type this in so you can turn this in, unless you want to, write it all out and then go back in and type it. In order to turn in the paper, you have to type this into the document on the Canvas, the Google document in Canvas to turn it in. So if you want to write it out first and then type it, feel free. And then you're going to do the same thing. I'm not going to do them all for you. So then you're going to do between Molokai and Maui, Oahu and Molokai, and Hawaii and Oahu. You're going to get all of those in kilometers, okay? That's what the scale gives us. Now, the distance between the two islands in centimeters, it tells us that in order to convert the distance kilometers to centimeters, you multiply the value by 100,000. So we want to multiply 150, okay, by 100,000 to actually get kilometers. So some people can just add on the zeros, which I highly recommend learning how to do that, but I just want to show you that if you do 150 times 100,000, so notice there are 1, 2, 3, 4, 5 zeros, okay? What did you get? You got 150 plus 1, 2, 3, 4, 5 zeros. So really, anytime you multiply by a power of 10, okay, with zeros like this, you just add that many zeros. 1, 2, 3, 4, 5. Okay, 150, 1, 2, 3, 4, 5 zeros. And I am at 15 million centimeters. So the distance between the two islands is 15 million centimeters. Okay, now the last column wants me to find the difference in the ages. Okay, well, Hawaii is still forming, the big island. So right now, its age is not set. It's still forming. It's still growing because it is over the hotspot. It is active. The volcanoes in Hawaii are active. We just had a big eruption of the volcanoes in Hawaii that you probably saw all over the news. It was pretty crazy. It was erupting forever. And it was very detrimental to their communities, as burning down houses as the lava flows through the towns. It's very slow moving lava, but it is hot and it catches things on fire very quickly because you can't really stop it. You just have to let it do its thing. So the Hawaii that is still forming is 0 years. Maui is 1,200,000 years old. So the difference in ages, since it's 1,200,000 minus 0, the difference is 1,200,000 years. Okay? So when you get to the others, it'll be these minus each other. So 1,500,000 minus 1,200,000, that's going to give us the difference in age of Maui and Molokai. So So you have to subtract the differences in ages. Okay, so you're going to want to fill out that whole data table, and I will let you do that on your own. Now, this last page, again, terrible printer. I just got new ink too, so it's not the ink. It must be the printer heads. I've cleaned them. It just must be an old printer. So now you're going to want the speed of the crustal movement in centimeters per year. Now, remember the traditional speed we find in meters per second, but this is such a slow moving thing. It only moves centimeters per year. Okay? If it moved faster than that, we'd be like crazy having volcanic eruptions all the time, and we'd have earthquakes all the time, and we'd have crazy continents colliding all the time. So this is a really slow process. Sorry. So it takes millions of years for this movement to be something that's noticeable. Okay, so what we're going to do is let's get Hawaii and Maui, between Hawaii and Maui right now. So I'm going to get, by using the data we just found. So the old data, we know that it's a centimeter per year, a distance per time. So this is our distance, and this is our time. So we know that speed equals distance divided by time. So I need to plug that into my calculator, or you can also cross out zeros, and I'll show you that in just a second, but I want to show you what that looks like. Oops, I should have just left that there. So the equation we're going to use is 15 million divided by 1,200,000. There we go. Now you could just go whoop, whoop, cross out all these lovely zeros, right? And you have 150 divided by 12. So I'm going to show you both ways. You can plug in all those fancy zeros and divide it by each other and get 12.5. Or if you crossed out all the zeros, you could just do 150 divided by 12. Oh, and you get 12.5. So that's kind of just a trick when you have zeros and you're dividing. So we know that this section from here to here moved about 12.5 centimeters per year. Now, plates don't always move exactly the same speed all the time. It's due to the mantle moving underneath of it. So the mantle has giant convection currents, okay? And they go like this. And as the convection currents go, the plate above it moves in the direction of the convection current. So these make big circles, and then the plate moves over it. And so if there's a convection current going a different direction, so maybe it's going this direction, that means the plate above it is going to move this direction. And what's going to happen to these two plates? They're going to converge. They're going to come together, okay? And usually, depending on what type of plate, one plate will subduct under the other, and you'll get mountains and volcanoes, okay? And sometimes, if they're two big pieces of continental crust, if they're big, thick plates, they don't subduct. And that's when you get big mountains that aren't volcanoes, like Mount Everest in the Himalayas and the Swiss Alps, the Matterhorn, okay? So when you have these big mantle cycles, you're going to get plate movement. And it could vary, but 12.5 centimeters per year, that's not very far, okay? So if you look on a ruler, 12.5 centimeters in a year, okay? And sometimes you might notice it's less than that on average. All right, so then your job will be, once you find out all of this information, so you have to fill out all of this data table, so get all the measurements between them, okay? You get all the time between them, the years, the difference in years, and then you get all of the speeds. You're going to get an average speed. So remember, average, you add them up and divide it by the number that you have. So you could add them up and divide it by 4, since you'll have 4 numbers, and get an average speed. And then you're going to answer these questions. And since you'll be in the document in Google, you're just going to type the answers right underneath each of these here, okay? And do note, it asks this first one, in which direction was the crustal plate moving when the Hawaiian Islands were formed? You're going to have to go back to this lovely thing here. So you got to know which is the oldest and which is the newest. So which way is the plate moving? And to know that, you may have to reference this one too. Okay, go back to this diagram. So use all three, or I mean, sorry, both diagrams. This one, use your compass, use this one, and see if you can figure out the direction that it was moving. Okay, so that is how you do this paper.